All right, we have something very unique that's about to happen. And it's about to happen because I want you to think about what process is taking place in stomach, small intestines, and large intestines. These are digestive organs, and the digestive organs are picking up nutrients from the outside world, yes? So your body has a little system set up called a portal system, and I just have to define a portal system right now because it's weird. A portal system, I think there's only 3 in your body, is a series of, I don't like that. It is a set of 2 capillary beds. I think series was a better word. In sequence. Okay, I like series. Change that to series. A series of 2 capillary beds in sequence. Now think about that for a second. If you're bringing fresh, delicious blood from the lungs, and I'm continuing the thought without dealing with this yet. If we bring good, healthy blood via an artery to a capillary bed, we get exchange. Like we're going to pull all the oxygen out of that blood, and we're going to get all the garbage from the cells and dump it back in there so that the blood that leaves in the vein is dirty. It's old, dirty blood. And the logical thing to do is to send it back to the lungs. Let's clean it up in the lungs. If you were to send this through another capillary bed, you send dirty, ugly blood through another capillary bed, you're going to end up with like death blood. Why would we do that? Because really, the cells in this capillary bed, the cells surrounding them, they're not going to get jack doodly out of venous blood. They're not going to get any oxygen. They're not going to get any nutrients. Like it all has been taken out by this first capillary bed. So this strategy is ridiculous and doesn't happen except for in 3 locations. And the 3 places that it happens for functional reasons. Like there's a functional need for a second capillary bed even though it's weird. Okay. It happens in the liver through the hepatic portal system. Now, capillary bed, feeding the stomach, the spleen, and the pancreas. Vein, draining the dirty blood. Please understand that there's nothing anatomically correct. We're not going to name these veins. They totally have names, and we're not going to name any of them. We're just going to say, you know what? They all flow into a vein called the what? Oh, you know it's true. It's the hepatic portal vein. Please, not anatomically correct, but let's label that thing. This vein that everybody's feeding into is the hepatic portal vein. And we're sending the hepatic portal veins dirty blood to the liver. Why? Because you just picked up a whole lot of crap, and your liver's thinking, I mean, your brain is all right most of the time, but sometimes you do crazy things and you poison yourself. Who would do that? And if you poison yourself, I want first shot at this before that poison goes anywhere else. So the liver is filtering the blood, making sure that there's nothing bad in there. Notice that we also have a hepatic artery. So we are delivering fresh blood to the liver. We are delivering dirty blood to the liver. So the liver can do its job because we're not just delivering dirty blood, but every single nutrient that was absorbed in the digestive system goes to the liver before being dumped anywhere else. Now let's just go ahead and finish the story because the liver ultimately feeds into, and this again, completely anatomically incorrect, what vein are you going to anticipate drains the liver? It's the hepatic vein. So blood from hepatic portal vein and hepatic artery travel through liver capillary madness and drain into the hepatic vein. And who does the hepatic vein drain into? Oh, you know it's true, the inferior vena cava. While we're here, there is a renal vein that also drains into inferior vena cava. And so I feel like it would be, even though we're talking about hepatic portal system, renal vein, how am I going to do that? Let's do like that. Renal, that says renal vein. I'll draw my kidney right there. Look, it's a skinny guy. I just want you to know that the renal vein is in there, draining into the inferior vena cava, and the hepatic vein is draining into the inferior vena cava. There's something else I was going to, I was going to show you how our hepatic artery and our hepatic portal vein is kind of set up in the liver. So I have a picture of a histology view, a microscopic view of the liver cells. And here it is. This is from the OpenStax textbook, woof, woof. This is my liver, gallbladder, yeah, fantastic. But if you look at the actual histology of the liver, and we could look at the slides. I've never found them quite clear. This I find quite clear. Liver tissue is organized into these really interestingly shaped structures called hepatic lobules. Do I need to write that down for you? We'll see if I can, because I don't see hepatic. I don't know if I can write on this. Yeah, it's not going to, whatever. This is a hepatic lobule. How many hepatic lobules do we have? One, oh, look, there it is. It's labeled right here. 1, 2, 3, 4, blah, blah, blah. Lots of lobules. Each lobule has a central vein down the middle of it. The central vein connects to the hepatic vein. So all these lobules are draining blood from the, blood has to travel through all these lobules in order to reach the hepatic vein. Okay, wait. At each corner of the lobule, you have 3 vessels, and one of them is a branch of the hepatic artery. One of them is a branch of the hepatic portal vein, and the other one is a branch from the bile duct. All this means is that these cells in here are being fed by the hepatic artery. They're also being fed by the hepatic portal vein. And they're also, they have branches connected to the bile duct, which allows those cells to produce bile and dump that into the bile duct. The blood moves from these outer triads of vessels toward the central vein. And as the fluid moves through, gas exchange occurs and filtering occurs. And then we dump into the hepatic vein. How's that? Super clear. Okay, we've got the lower limb. That's it, and then we're done. So let's do that one next.